this is continuation of page 47. Now, on the direction, it says to find the values a and b that make the function f of x differentiable. That means we know that we're going to have to make this differentiable. Now, let's talk about what differentiable is. In order for a function to be differentiable, it must be continuous. Okay? And to check the differentiability, we basically do exactly the same thing as continuity, but on the derivative. Now, just like the other ones, we're going to have to check the left and right, but this time we're not checking it. We know for a fact that they're going to be the same, so we can go ahead and do the continuity part here and say, okay, so I know that my limit from the left, which is the top one, is equivalent to my limit from the right, which is the bottom one, at 1. So we're plugging in 1 to both of them. Now we can go ahead and make this prettier, and this becomes a plus 1 equal b minus 3. Okay. Now, we're going to do the same thing, however, we really need to work with differentiability now. So we know it's going to be continuous, and we also know that it has to be differentiable because they told us. So now let's work with our derivative function. Okay, we're going to get the derivative function by just taking the derivative of both top and the bottom, so we get 2ax, and our limitation is the same, and just b, because b is just a constant multiplier. Okay, now let's work on our differentiability here, or derivative here. So we're looking at it at 1. So limit as x equals just 1 from the left side of the derivative is just 2a times 1, which is from the left side. We're saying that should equal to b, because there's nothing else to plug it on the bottom, so we just bring that down. We know that has to be equal to each other because it says that it is differentiable. That means the derivative from the left should match with the derivative from the right. So this gives you 2a, I don't know what's going on with my phone, with my pen, it's 2a equal b. Now once we get here, we're taking a look at both of these. What can we do to both of these in order for us to find a and b? In class, we talked about that we would substitute. We see that b is 2a. So wherever the b is, we're going to substitute that with 2a. So we now have a plus 1 equal 2a minus 3. And we're going to solve for a. So a equals 4. And once we got here, we got one of the answers because we're supposed to find a and b. And to find b, we're just going to plug the a back in to this one. And that's going to give us b equals 8. Let's do one more practice. Likewise, on part B, instructions are the same. They're saying it is differentiable, and find a and b that's going to make it differentiable. So since it is differentiable, we know that automatically it is continuous. So let's check the continuity part. Well, we know that it is continuous. So we know that if I plug in 2 into top one and the bottom one on my x's, they should be the same. So if you kind of work this out, 2 cubed is 8, so we get 8a plus 1 equal b plus 10, and that's as far as we can reduce as of right now. And we're going to go on to continuity part, but we need to have and then we're going to go into differential part, but we need to have the function for that. Our functions are going to be 3ax squared, because a is a constant multiplier. Limitations are the same. This will be 2b x minus 3, and the limitation is the same. I know I did Canadian wrapper out of 2b. That gives you 1 times by 1. If you want to put that, you could have done that as well. Let's do the differentiability part. We know that if I plug in 2 into both of these, it needs to be the same. So it's 3a 2 squared must equal 2b 2 minus 3. 2 squared is 4, so now 4 times 3 is 12a equal negative 1 times 2 is negative 2b. So our b is negative 6. Now we're going to plug in our b in here to get 8. Oops. What is going on? So we'll get 8a plus 1 equal negative 6. Negative 6 plus 10. This is going to give us 8a plus 1 equal negative equal 4. 8a equals 3. So a equal 3 over 8. Alright, I hope this helped.